To find the horizontal asymptote of a rational function, you have to follow these 3 steps. But first, you got to know what the form is of your equation. And the rational equation is be given to you something like this. Now this looks really ugly, but don't worry about that. All you really need to be focused on is the leading term of the numerator and the denominator, the leading term at the top and the bottom. That's all you need to be focused on. The rest is irrelevant for a horizontal asymptote. So, given the rational function in this form, in which the degree of the numerator is n, the green n up here, and the degree of the denominator is m, the red m down here, these are the 3 steps. If the top is less than the bottom, then y equals 0 is a horizontal asymptote. If the top degree is equal to the bottom degree, then the line is going to be y equals a over b, the coefficients of the terms. Third, if n is greater than m, then there is no horizontal asymptote. However, if n is equal to m plus n, if it's just one more, then there is an oblique or slant asymptote, whichever word you prefer to use, oblique or slant. And to find that, you have to do long division. Just know that you cannot have both a horizontal and an oblique at the same time. If you have a horizontal, you can't have an oblique. You can have one, you can have the other, but you cannot have both at the same time. So find the equation for the horizontal or oblique asymptote for each function. So f of x equals 3 over x plus 4. Well, the degree here we can say is just x to the 0 power, and this is x to the first power. So since the power up top is a 0 and the power in the bottom is 1, that means that the top is less than the bottom, or the bottom is more than the top. So when this is the case, when the bottom is more than the top, the horizontal asymptote is just y equals 0. That's it. Now for this one over here, we have a degree 2 up top, and we have a degree 3 in the bottom. So, since the bottom again is greater than the top, the horizontal asymptote is just y equals 0. Again, that's all you have to do. Next, we have this function here, and I look at the degree of the top, which is a 1. I look at the degree of the bottom here, also a 1. Since they're equal, the horizontal asymptote is just going to be their coefficients in front. So it's going to be y equals 4/3. And that's the equation of the horizontal asymptote. Now over here to its right, we have a degree 3 up top. We have a degree 3 in the bottom. They're equal, so we just want their coefficients, the -7 and the 4. So the horizontal asymptote here is going to be y equals -7/4. Again, the rest of the parts in the top and the bottom, we don't really care about. Last, we have this function here, and we can see that the top has a 3 and the bottom has a 2. So since the top is greater than the bottom, there is no horizontal asymptote. However, because it's only off by 1, there should be a slant or oblique asymptote, so we're going to do long division to find it. Now, long division sounds really bad, but the nice thing here is we don't have to go very far in long division. We just have to take it at most 2 steps. 0x² plus 0x plus 1. And so doing the long division here, off to the side, x³ over x² is going to give us x. So that's what goes here. Distribute the x in if you've forgotten how to do long division. x³ minus 5x² minus 14x. Subtract, and we're going to get positive 5x² plus 14x plus 1. And do it one more time. 5x² x squared over x squared is going to give us 5. And now we can go again and do the plus 5 distributed over, but we really don't need to because the rest of it's irrelevant. We only need this part here. So once we get to this part, we're done. So the slant asymptote is just going to be y equals x plus 5. No need to finish off the long division. Once you get those two parts, once you get that, you're all finished.